Hello, Chad. So, what are we doing today?
What I would like to see is a to take what we already have on the remote development branch. So we already have a module there for remote dev on CAS and on Agent K. And there's some polling on CAS and there's a for loop in Agent K. But to see if we can just spike on transforming that into the architecture that we've currently converged on.
Okay.
Hello, Guillermo. Which is that Agent K will have a polling loop and it will make a request directly to Rails, proxy through CAS. Rails will accept that, give a response, and both of those are optional. Like the request will optionally contain some, a desired or an actual state as represented by the events, but we don't have to do that. I'm just looking for the communication, and the response will contain possibly some work to be performed to have it attempt to converge the desired state with an actual state. But just looking at what I'd like help with is you said that there is a way that Agent K can, directly call a Rails endpoint and just have CAS proxy it through with little or no code on CAS. And for the first iteration, that's what makes this most sense to me. Shakar is, definitely talking about if we could have an event-driven approach. There's definitely performance concerns with this, like a long poll would be better, and then have CAS do the polling, but we can refactor towards those, in the future if there are performance issues. For now, let's do the simplest thing, which is just a poll driven by Agent K
Mm-hmm.
in a simple loop. What do you think? Does that sound like a reasonable approach?
Mm-hmm.
Yeah.
Yep. Okay, let me go
And
to
there's really not any example. Like GitOps is sort of like it, and then the other thing is sort of like it, but they're all like more complex than this needs to be, I think, for just a
I
single
think I
request.
think the container scanning module is exactly what we need,
Is it? Okay.
actually. Yeah. Anyway, let me share.
So you could probably just like make a branch off of the remote dev branch and just turn it
So,
into whatever you think this should be.
um, so remote dev,
Right.
this branch or some
Yep.
other,
Nope, that one.
this the first
And
one.
then we currently have a couple of branches off of this for like stuff we have in progress, but it will be informed by whatever you do here. We'll like take this as
Mm-hmm.
inspiration and copy it into ours.
Mm-hmm. So remote dev,
Did you
I
have
just want to.
anything to add, Guillermo, before we get started? Did what I say make
Um,
sense?
yeah, no, that makes sense. And thanks for explaining it, because I was actually going to ask, like, I don't get exactly what are our two options here, but I didn't realize it was like something where Agent K could directly call Rails, or like directly, indirectly. It's still through CAS, but
Right. Like there's
CAS
many
only
different,
proxies.
and there's like we could have CAS poll, but like we don't need to. So let's keep it as simple as possible. And like I was talking to Shakar this morning, like yes, we could have sort of an event-driven architecture, but that would imply CAS has some state somewhere. There's something externally that is sort of has a scheduling loop, but this is the
Okay.
absolute simplest architecture we could get. So let's go with it first.
This looks what we currently have here is that makes sense. Yep. We get work, we parse it, and we apply it. Yep.
So the part that I was vague on, and this was what Vishal and Guillermo and I were looking at, and Guillermo, I definitely know Go better than me, but we want this to be like on a one, an in second poll, like 1 second or 5 seconds, whatever we decide. And like, where is that happening? The wait,
Here, you mean? Or
right?
Mhm.
It's like this
Yeah,
should
we were sort of confused between the polling that Agent K was doing versus a polling that Cas was doing on our current code. I think Vishal copied it over from GitOps, but I think on Cas it was something like an RPC structure, internal structure that's part of the project. And in here, at least so far, I only see like this infinite for loop. So like I don't know if the waiting is happening somewhere else
there's
or
no
there's no
waiting here.
wait.
Yeah,
There's no waiting. Okay.
as you say,
Right.
it's an infinite loop without any waits.
Yeah.
So the part that I'm confused too is like the Git work, like that is defined in Cas. And when you say that there's a way for this to talk directly to Rails, I sort of assumed there would just be like a proxy that it would.
Yeah, well,
go
this doesn't do what we discussed. It
Okay,
doesn't call Rails directly.
That's what
It
we
does
want.
what you think it does. It calls Cas, and Cas does whatever it does here.
In this
Which
case,
is-
called
which is
Rails
this.
with its own poll with backoff, which is
Yep.
possibly what we would want to have, but on the Agent K side, the poll with backoff, because that
Yep.
has the built-in like polling time and everything.
Right.
So if you just want to call Rails, then let's look at container scanning. This one. You see, it doesn't have the server module. Let's start with the factory, and let's start with config. And
Just for context, starboard vulnerability is a container scanning.
well, yeah, I don't
Okay,
know why
okay.
I called it container scanning, starboard vulnerability.
Okay.
Yeah. So what you want is this API thing, and it has the make GitLab request method. That's what allows the agent module. This is the mod agent. So this API is injected into each module. So you can just call GitLab basically magically through Cas with authentication taken care of. So you see it gets that from the config in the
So this
factory.
can call any path and it's a JSON REST request.
Not any. It goes, maybe it's documented here. No, it's not documented. It's documented somewhere, I'm sure, but I don't remember.
It's like built from the
Docs.
internal modules, like a path underneath there, right?
Yeah, yep. So
Yeah.
you can see that in the implementation.
It corresponds to the name of the module.
Make request. Yeah.
Which
We've
actually already wired this up on one of the other branches. Like we made this endpoint on Rails and had it call it, but we just want to be calling it from Agent K instead of Cas.
Yeah. So yeah, so this is it's called GitLab Access, the server part. And that's what it is being called here on the server. And it goes, where is it?
So this is on the Cas side, right?
Yeah.
Yeah.
Constructs the path somewhere. I don't remember where.
I think, is it like the Asian RPC API from context? Line 28? Somewhere in there? No.
It's here. So module, that is the path. Then it puts the module name after it, and then you can call a subpath, any subpath. So you can call any endpoints underneath this path, basically.
Which this is fine. I think the part we're looking for help on is like, how can we do this? Like just pretend that URL exists and is something put on the Agent K side with the poll with backoff around it.
Yep. So let's look at how this thing does it. Yep, that's how it calls blah, 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 starboard vulnerability, policies configuration. and it wants a get and gets the response and checks the status and blah, 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 reads the body. You work with it as if you're just talking to Rails.
And we have this working on one of the other branches that you saw in there, but from CAS, not from Agent K.
Yeah, in CAS, there's a very similar API that you are using. So what you are using is used by this thing. So you just need to use this thing from the agent.
So maybe let's focus on like getting, since that seems like we've already mostly figured that out, could we focus on getting the Agent K converted to the poll with backoff loop and then just maybe like make it log every second, and then we can do the work of wiring it up to actually do the request? So instead of the for loop, change it to the poll with backoff.
For polling, let me see if there's anything for polling. No, there is stuff for polling on the server side, but on the agent side, you just need your own configuration for polling, which you can just create.
So you wouldn't reuse that poll with backoff stuff? It would be, that's only works on that?
That code exists on the API as a method. It only exists in the server. But on the client side, you can just do what, I don't know, this thing does, which does what? Yeah. So basically you use this function, plus you give it the config, and the config, you just construct that config, something like that. Yeah. Just set the timings. So here's an example, basically. Like, interval, where is the interval? Interval, well, in this case is 0, but this one is a good one. So interval is 5 minutes, and then like back off, max back off, start from scratch after there was an error, like after 2 minutes, and back off factor is 2, and jitter is 1% or 100%, not sure. But yeah, you can construct the polling config basically. Then you can use that like this. Where is it?
Sorry if it's a silly question, but just to get like the terminology correct, the backoff interval would be like in case in this case Rails API responds with an error. The default interval would be for like every successful call, and then what is the jitter?
Jitter is the jitter of the interval for polling. So and for backoff as well. No, I think it's only for backup actually. So if there was an error, you don't want all the polling agents to keep polling at the same moment, even with backup. You want them to spread the load a little bit. So if there is an outage, you don't want all the agents hammering the API at the same moment, even after backup. So you want them to be polling slightly at different times, so that the load is spread. You don't get the spikes of requests.
So the percentage is like the percentage in variation of the real time. Okay.
Yeah.
So that's like if you have an outage and the cache is cold, you don't want everything like hammering it immediately, right? At the same time.
Yep. And
but I guess what would a natural or like sensible value for the jitter would be? Because here it's like 1% of 5 minutes.
I think it's probably, I'm not sure if it's percent or what is this. I just don't remember. Okay, I need to look at the factory.
The thing is, if we're doing
jitter
polling every second or every 10 seconds or whatever, like the scale is very different than 5 minutes. So I don't know how much the jitter would help, or like if there is at any point a conflict where the jitter, depending on the value for it, like is it a percentage or something?
So jitter is between 0 and 0 multiplied by duration. So 1 means double, basically, from, well, you have the interval plus maybe from 0 to the same interval of jitter. So it's quite a lot. It's not 1%. It's like 100%, basically. That's one.
Yeah, 100%.
That's what 1 means. And this is from Kubernetes. This code is API machine code.
Okay.
Just to reuse that stuff. I don't want to write my own. Yeah, you can see the docs for it. Just drill into the code a little bit and configure it the way you think it would be the best. So again, look at the factory in ChartOps, the GitOps basically submodule, and yeah, it just constructs the config, and then like polling is this basically, and then this function that you provide is called whenever is the right time basically, and then you have so it returns when you return an error or you say that it's done. So the attempt result is what your function can return, and like continue means continue with polling with the interval, or with the interval. Immediately means like call me again right now, basically, unless the context is canceled, like it checks the context. And back off means there was an error, like call me a bit later, depending on the config. And done means stop polling, like I want to return from the poll with back off. And then as you can see, this thing never says done. On error, it returns back off and just continue forever. So this thing is aborted.
What is the difference between continue and continue immediately?
Continue allows you to poll with the interval, like let's say 5 minutes. So it tells the function to continue polling at 5 minutes intervals. Also with jitter, or maybe no, jitter is only for errors actually, I think. So continue in 5 minutes, and continue immediately means call me immediately. It's like a title. This is used
don't wait
in
anything.
Don't wait at all. This is used in some places actually.
So is the continue counted from when you return, or for when the loop started? The duration.
You can control this with sliding, whether you start timing from the out, like before you call, or whether it's period, or whether it's
from when you start or from when you end.
Yeah,
we want it from when we start, because we wanted to say, like, if it didn't take the full interval, go ahead and wait. But if the request took longer than the interval, do it immediately. You can do that.
Yeah, you can configure that using the sliding boolean.
Okay.
Basically, the answer is we can choose.
Yeah.
However it works. Okay.
Yeah, you can look at the code. Yeah, I copied from Kubernetes and rewrote some of the internal loop logic to add. Well, first this switch, and the second, like this immediately option is not available in the Kubernetes helper, but the overall structure is from Kubernetes helper. Just tailor it to what I needed, because in some places I need this immediately, and it wasn't available at all.
So if you look at so this is like in worker 3. If you look at just the plain worker.
Oh, there are plenty of examples actually for this, but yeah.
There what?
Plenty of examples of this function, how it's used.
So like this installer upgrade, like that's called from the worker?
Yeah, this is on the agent side, and this is called in a Go routine. This starts a Go routine. So it just loops until jobs channel is closed, basically. Or context is canceled, context of the job. So when context of the job is canceled, this aborts and it starts waiting for the next job, basically. And then if jobs is closed, this exits, and then the Go routine exits.
So our worker will just have like a single Go routine and then a single, if we follow this, like worker one, reconciliation loop.
Yeah, you will just have this thing. Context will be
Would we need a Go routine?
Probably not. No, in this case,
Yeah, because we only
more things.
want to poll eternally.
The Go routine is only because you're multi-threaded and you're doing multiple polls
Yeah.
in parallel,
Yeah.
right?
Yeah, multiple
Well,
jobs.
This is doing polling concurrently with other things. That's why it's in a Go routine. And if you don't
Right.
want to do it concurrently with other things, like you just run it in the Go routine of the module itself.
And at some point, we'll probably want some mechanism to like immediately like accept a request to say, give me the state of this workstation or give me the state of all of these workstations. Like if you don't want to wait for the next poll, or like you want to force a refresh if you think for some reason the state that is persisted on the Rails side is out of sync or something, you could say like immediately refresh and send me all of this information. Would you see us hooking that into this polling loop? Like if you don't want to necessarily wait for the next poll, or would that just be a separate request implemented independently? That's just synchronous.
So it depends on how you want to do the deduplication of work, like to mark the jobs as in progress, update the status.
I guess we could spin off a Go routine from within the function within poll with backoff. Like if whatever we get from the answer from Rails triggers an alert or a condition that we need to do some sort of work or reset on the workspaces, we can do that in the background there.
And yeah, that will have polling. To be.
In fact, probably any work, like even if it's like not necessarily like error reconciliation or anything, like any work.
Yeah, that's the plan. That will be in parallel, and then that work will get kicked off. It'll happen whenever it happens, and then every loop is like, what are the new events for every workstation that I care about? Okay, take these events, and we're going to send those as the new actual state back to Rails.
So using the same endpoint for both updates and get work,
right?
I mean, it makes it more difficult to, like, what would you do if you need to send updates, but you have the get waiting for the reply? I mean, actually, replies are instantaneous in this case, right? So like it won't be kind of blocked.
Yeah, there's nothing that would be blocking. I mean, we have the choice to do the processing we have to do is to transform the Kubernetes events into like a representation of the actual state. So presumably that's like a fast operation. So my initial inclination is to do that all on the Rails side. Like
on the Rails side?
To make the agent K as dumb as possible, right? So then what Rails has to do is basically it's just processing whatever information it got. It could be the raw events, it could be pre-processed before they get them, either way, and apply them to the database and then do a query to say, okay, based on the current state of every workstation where the actual and the desired are different, do I have any work requests to send? And then it will generate that. But that is all, there's like no remote calls. It should be basically an instantaneous request as fast as the database can respond to it.
Yeah, the request, the only requests that Rails could make would be like, start this new workstation, stop this one, restart this one. It's probably not that complicated.
It's stuff like that. So a synchronous request, and the benefit of doing it in a single request is because when you're listening for the information, like that may contain some new actual state. and then you generate the work based off of that latest information that you just got. And then we're also keeping a timestamp of, we'll echo through a timestamp of, for each workstation, what is the events we have processed that have been successfully applied and recognized and processed on the Rails side. And then when that comes back to the agent K side, then it will know, okay, all this is done. Now I can, on the next poll, send any new events that are relevant to that workstation. And of course, each agent, it'll be an array of workstations, however many it is managing, the same information with a timestamp for each one and info and work coming for each one. So they will be large, potentially large payloads, but these are not a lot of traffic. So that's the other point that Shafar brought up. But we can do the math. Like if we poll, once a second, that's 360, an hour or whatever. Whatever that traffic is multiplied by however many, workstations we have across all of the agents. And there's multiple levers we have if there's performance issues there. We could reduce the polling interval. We could have more CAS in the pool to handle it. We could have, if the bottleneck is on Rails, like it would just be the database would be the only bottleneck there. But if we got looped quick, I think that should be okay. That's far from our most busy table, I would think.
Yeah. And we could consider not polling every second, like maybe every 10 or 20 seconds.
That's what I said. Like we can always back that off. And then the only consequence of that is like the users are going to see updates less frequently, right? They would see.
Yeah.
And that's why
I guess this is something that we can iterate on, but
we have something that we can say, okay, right now I want to push refresh, and that will do like a synchronous outside of this polling loop. Give me the latest info for all of these.
Refresh now or something.
Create a Kubernetes
like a further feature.
All the info for these. And it will be idempotent on both sides. Like if the agent K receives work that is already in progress or being applied, like
it just ignores
it. Okay, it will reapply it and it will be a no-op. Same thing on the Rails side. If it receives a
this workspace has already started.
An actual state that is redundant, like it'll just rewrite it in the database. It's fine. It's idempotent. Either of them can receive duplicates. And then the one thing that's left is like, well, what if, CAS or Agent K or Kubernetes or whatever, like just drops one of these requests, it's gone. There will be on the Rails side, like if there's some state change it's expecting, like I'm waiting on this workstation space to be provisioned. And like there's a timestamp for like when I got the last actual state of this, it started going from provisioning requested to provisioning. If that's more than like in minutes, like 5 minutes is the longest it should take, it could just resubmit that work request to say, hey, maybe this request got dropped for whatever reason, I'm going to resubmit it.
If it's idempotent, it could just send it back every time until it's in the desired state.
Like we're trying to make this less chatty. Like it's going to be big payloads and a lot of traffic anyway. So like try to make it at least send only when it needs to send on both sides.
So which agents will be polling? All of them? Like this feature is.
So the traffic would be like all of the agents multiplied by the.
So you don't want to make it like opt-in. You just want all agents to always be polling.
Yeah. Why would we not?
Please help me out with like the infrastructure part. Like we would have like one agent per Kubernetes cluster, and each client could have one or many Kubernetes clusters.
Correct. And,
correct.
Yes, and Shakar actually made a picture of this this morning.
You can also install multiple agents in a single cluster.
Right. can't attach files in Zoom, can you?
No, but you can share your screen.
Sure, let me bring it up first.
And it also be in recording.
Right. This one. It's an SVG. What do I open it in? Open it with preview. I guess the browser. There we go. Let me zoom this down. Yeah. So sharing my screen. This one. Yeah, this is, so I need to still reflect what you, Vishal, and I talked about Friday or Thursday, Guillermo, but I was like reviewing the web IDE and helping with some backend on that. And then this is what Shekar and I talked about this morning. So there's this, and then there's the architecture. Copy this one here. So like this is the high level of it, right? The agent K is subscribing to the events. It gets the events. It's no longer a long poll like that. That has changed with this idea that we can proxy it through. So it's just going to post this request. It's got any, actual state. That's a better terminology, but whatever status info it has. And then Rails applies that in the database. If there's some work that it needs to generate, tell Kubernetes, bring this into this state, start a workstation, terminate a workstation, whatever. And the response it will receive to that. And then, like you said, in a Go routine, we'll kick off dev workspace operator to do whatever that is. And then it will go do its thing. And then each agent will still be polling for any new events. So like once that workstation is provisioned and is started, we'll get that event, and then that will be sent back over and reflected here in the Rails database. And like this is just a little bit more of a drill down to the details of how that worked, but still not with the timestamp. So I wanted to make some additional diagrams like representing how the timestamps work. And to your question, Guillermo, like, yeah, here's the monolith. There's multiple CASs. Each CAS has a multiple agents talking to it, and each agent can be responsible for multiple workspaces. And here's sort of the state that we did. So like there's a desired state and an actual state. Like this is represented in Postgres, and every request we like do a query to get where are they different, and is this something that I need to generate some work for? In some cases, it won't be. Like if the desired state is started and the actual state is provisioning, it's like, okay, I'm waiting for this. But then maybe there'll be a timestamp associated here. It's like, okay, if I've been waiting 5 minutes, I'll go ahead and resubmit a, provisioning request or, a started requested state. And so no premature optimization. My assumption is like this will scale. It's like the number of workstations everywhere times however often we poll is what will actually be hitting the Rails API. And like, I know we have a lot of high traffic endpoints and a lot of high traffic tables. It doesn't seem like this is going to be one of the worst ones, but we should do the math to see what we expect it to be.
Yeah, I think 1 second is way too often, if you ask me.
So
yeah. Also regarding Mikael's question earlier, like not all GitLab agents will have remote development environments set up with them. Like there could be multiple CAS, as you mentioned, and maybe only one is tied to a Kubernetes cluster that has the remote development environments. Or it could be the case that a client specifically doesn't have that functionality or hasn't provided their own like development environment, etc.
right.
So maybe we should have a way for agents to know whether they need to be polling or not.
And I'm assuming I don't know how does it work, Mikhail? Like there will be some metadata like that we provide to the agent that says, your remote development enabled or not, right? That can control that.
Well, the only metadata is configuration file plus some information about the agent itself. That's what you get in the get configuration. That's what you get in via the channel that gives you the configuration objects. If you open your module, you will see that object that you get. I can show you, or you can open.
Oh, that's fine. I'll stop share.
Um,
And I was thinking, Shakar and I talked about this morning too, like the polling interval could even be dynamic. Like we can control that from the Rails side and have it passed as the metadata along with the request.
This is the
Is the configuration dynamic, or is it loaded whenever whenever cast starts?
Configuration for CAS, so for CAS, the configuration is static. So CAS starts and CAS reads the configuration from a file and some environment variables, and that's it. But the agent is dynamically reconfigured through this channel, basically. Agent is given the configuration that is the configuration file plus some extra things here. Agent ID, project ID. And the rest is coming from configuration file. So if you add stuff to configuration file, that's when it's enabled or disabled. Presumably the user would want to configure the agent to, for example, create workspaces in a particular namespace. Right, so that's configuration, and that can be, if it's configured, then that means this module should be enabled. If you want to do it this way, but like starboard vulnerability module always pose, for example, because configuration for the security scanning can be added by the user interface, and for that there's no need to enable it. But there is also configuration if you enable it like that. But that creates, how many people will use this as a percentage of the agents? Probably not everybody. Like maybe, I don't know, less than half, definitely. So everybody will be creating load on the infrastructure because that's not, that's not opt-in, that's kind of, and you can also opt out. But we also have the idea that everything is enabled by default, right? So I don't know what needs to,
we could add the configuration, but have the default be it is on, and then people can opt out of their agent doing polling on remote development, which I guess people would only, if that default is for it to be on, people would only go in to disable it if like they're debugging something, or like the infrastructure is getting hit hard with lots of requests or whatever. In which case we should either way like change a bit of how frequently we're polling or whatever. But so yeah, I don't know. Maybe this is a bit of premature optimization.
And so Shakar he wants to talk about an alternate architecture that is event driven, where like events are coming from the Rails side, and then information coming from the agent K side, and CAS is reconciling this, which that seems like it will definitely address the load, right? And the chattiness and an event driven architecture, but it's conceptually more complicated, like you said, when we initially proposed that. The polling is easier to reason about. But if we have lots of levers, we can reduce the polling, we can do whatever, but we can also say, all right, this is still the same basic architecture, but like it's not going to send any data from CAS unless we have it, and then use the other, RPC direction to, it will always respond to any new state with the work. But if there's new work that's just initiated by a user, like create a new workstation on the fly from scratch, there's nothing triggering that to happen. It's not responding to some existing state on the agent K side. We could just have like an endpoint that is pokes it, right? Through Rails, through the gRPC interface to CAS, through to agent K and say, hey, agent K, just do a poll, right? Do a no op to kick off this loop, and then it will receive.
Okay, yeah.
So that would
So-
be a lever to optimize this, but still with the same architecture, essentially.
Yeah,
Yeah.
it would still be like agent K always polling, but we can reduce it to only poll when it has relevant information and poke it whenever we want to.
Exactly. So
We
it's the
want
same
it to
basic
poll.
architecture with like an optimization to not poll, basically.
Yeah. So this is what I had in mind, what I suggested, I think, in Slack some time ago. The only difference is I would poke CAS, not agent K, and CAS would do an immediate poll. And agent K would, just like GitOps, just wait for a reply. And then that poking can be Rails calling the gRPC endpoint of CAS, and CAS doing a broadcast for all CAS instances through Redis. So that, like, hey, CAS that is polling for workspaces for agent ID 10, do a poll right now. And then
Which are all things we can do and are probably good ideas. But while we're iterating on what it is,
Yeah, it would be like a second
the shape
iteration
of
because
everything, do it as simple as
exactly.
possible.
Exactly.
yeah,
That's
that would imply more logic in CAS than
Yes.
the very base simple thing we're talking about
Yeah.
right now, which is just like calling Rails directly from agent K.
Exactly. That's
And if
that's
we
what
iterate,
I wanted
it's
to
like
say.
faster to iterate if the shapes of these, communications, the only place we have to change it is like on the agent K side and on the Rails side. And then we iterate and we like, okay, this is how it works. Then we can say, all right, how do we optimize this? Like, and then if we have to make CAS smarter and it knows about the structure of these, or maybe it's got its own polling, like that could be in the future, but there'll be less churn if we
Yep.
have the simplest architecture possible while we're working out the basic communication and state management. Does that make sense?
Yep.
Yeah. It's just we have to take in mind that it might be a bit inefficient, and I don't think inefficiency is a problem, but I think maybe saturating the infrastructure could be a problem. So we just need to be aware of that whenever we turn this on.
Right, which is why one of the priorities I think should be like have, get it on Eric's radar, somebody's radar. Let's do some back of the napkin math. Like how many customers do we expect? How many workstations over what period of time? And, with this polling interval, this would be X load. And also like how big are these payloads? Like if we just send over the raw events from Kubernetes filtered out and let Rails do those, would that be like a meg per request? Would it be like 20 meg? And then just do that math and like, do we think Rails can handle
And if it's a problem, we can start pre-filtering them on the agent K side. And if it's not a problem, we don't need to optimize that.
Exactly.
So I have another thought here. With the agent, we model the permissions as the infrastructure team owning the agent and granting permissions to developer teams. Obviously, it can be the same person if it's a single person shop or something, or someone is playing with it. But we have to be able to split this into different teams owning different owning the agent and using the agent. And for that, in some cases, I think the infrastructure people who own the agent would not want developers to launch workspaces in that agent. Does that make sense? I think it does. Like for a production cluster, maybe you don't want people to start workspaces in that agent. So
why didn't you tell us this when you first suggested using GitLab agent for Kubernetes?
No, but
I'm
it's
just
okay.
giving
It's
a hard
just
time.
we're just talking about a configuration, right? Like
Well,
Yes,
maybe
you
that
said it
should
would
be
be
in the
different
initial iteration, like
pools.
just full level on off for remote development on a particular agent.
Sorry, could you repeat the question again?
What we were talking about earlier, like having some sort of configuration, whether the default is it's on or the default is it's off, but having it in the configuration, whether we want a particular CAS to enable its agent case to start polling for remote development environments or not.
Well, for GitLab.com, we have one CAS. I mean, multiple replicas, but it's logically it's a single CAS, right? For a GitLab installation, you have only one CAS. That's the server-side component. We don't run different CAS instances for different teams, you know. So it's
okay. Then it's
can,
not the diagram where you were showing us earlier, Chad. We need to update it.
Well, what are you saying? That different agents have different responsibilities and permissions?
So imagine you have a platform team. They run 10 agents, like 2 in production and I don't know, 2 in staging and other whatever testing agents, right? Then
by 10 agents, you mean 10 agent case? I'm sorry, the terminology is a bit confusing for me. Okay, 10 agent
10
case.
Agents. Yeah, and then you know, they grant access to developers only to certain agents in certain environments. By filtering by environment is going to be in this release, I think, or in the next release.
So like
and
agent K might manage, A and B might manage workstations, but there's like, you know, E, F, and G that don't.
That because the platform team doesn't want you to create your workspaces in the production cluster, right? They want you to create them
for us.
Sorry?
That just means the implication that the only implication of that for us is like we just don't start this polling loop unless the agent is configured for a remote dev.
Exactly. That's what we can build on it's always it's enabled if it was enabled by the admin, so it becomes an opt-in. And this would be consistent with other features. GitOps is opt-in, CI access is opt-in for most of the projects. Like it's only enabled for the agents project by default out of the box. For others, it's opt-in.
So it would be config based
consistent, and that would be based on the configuration of this particular agent. And that configuration is sent by CAS to the agent, and the agent can look at it and decide should it start the polling loop or does it need to.
That's the only difference, at least for the initial revision, basically.
That doesn't
should it
change,
start that polling?
Yeah, that doesn't change the architecture. It's just an if condition, basically. Should this happen, or should I just like don't do anything? You know?
Yeah, exactly. And as for this diagram we're currently seeing, so is this a possibility or is this incorrect? Like, can a single GitLab instance, whether it's GitLab.com or like a self-hosted or whatever, does it have multiple CAS? Or can it only have one CAS?
Well, logically, it's a single program, but it has currently 18 replicas running.
And one is elected the leader, and that's the one that will be.
Well, they don't have leader election. CAS is it's a single cluster of things. They talk to each other, but logically, it's a single thing. Any of them service any agent.
Right.
It doesn't create any problems. If you think
the way
how can it go wrong, it's okay.
Right, and the way the database will be structured is like this will be indexed by like workstation ID and index or an agent ID. So like these can come in parallel, and it's only going to update the records that it cares about.
Yes. So to limit. So in the agent, we have the leader election. So for, let's say, agent KA, it's like agent ID 1, and agent B is agent ID 2. They're separate agents, but each of them can have multiple pods because the user deployed 10 for whatever reason, right? So each of them can, each of those 10 agent KA will do the same thing, right? Because they will all get the same configuration. It can create problems. For some features it doesn't, but for some it may. So for those that where you don't want to do the same thing, you do leader election. This is available in Agent K already. GitOps uses that. Container scanning uses that. I think that's it. Maybe.
Yeah, we'll definitely have to do that because we want to listen to the single stream of events for.
Yeah, you probably don't. Yeah, you don't need to run multiple because that creates multiple polling loops, and there's no point in that, right?
Yeah, it wouldn't be wrong, but it would be inefficient.
Yeah, well, yeah, it would be inefficient. Yes.
Well, it'd also be inefficient.
You would send multiple things, and then that just complicates everything.
And we want like large payloads are okay. Like these are going to be, wide area, like they're wide area connections, but they're going to be good connections, data center to data center or something like that, ideally. So you can send large payloads, but fewer requests. That's okay in general. Because the bandwidth is good, and we just want to reduce the request frequency as much as we can.
Yeah, we don't want to have empty requests like just hammering CAS. We have Cloudflare, then HA proxy, Google Cloud Load Balancer, CAS. They will all it's wasted bandwidth, wasted CPU cycles,
right?
In the end,
so
wasted dollars. So we don't want.
The first obvious optimization is okay, it's not really polling. It's only send something when it has it, and then Rails sends a poke. I have some new work, and then it will trigger the same process again.
Well, this is how GitOps works. Agent K connects and waits for CAS to reply. CAS replies only when it has something to reply with. And then connection times out, Agent K reconnects every half an hour or so.
Right.
So
but if go ahead, sorry.
Request per second stays low basically because of that. That's good. We are not wasting money basically.
And
that's basically the infinite for loop we were seeing that we copied over from GitOps, right? Because it gets work, and then when it attempts to get any further work, it just waits until there is some work to get.
And so if we go with the philosophy that as much of the logic as possible is going to live on the Rails side, right? Even the parsing of the events maybe, but definitely the logic to move things through states, to compare desired versus actual, decide what work needs to be requested. If that all lives on Rails, it's more of, not simple, but it's more of a straightforward architecture change to say, okay, we're moving from the polling being on Agent K to CAS, and it's not that big of a deal because you're not moving processing logic around, and you're just changing where the polling is happening, but it's still essentially the same data being passed through. Minimally unprocessed.
What we are discussing doesn't change the architecture. It's just an optimization that we'll be able to do later.
But that's a reason to err on the side of, prefer to put all of the logic in Rails. Also, Ruby is a lot faster to write and iterate on. We can deploy it. If there's bugs, we can fix it, all of those things.
Well, definitely versus asking customers to upgrade the agents.
Exactly.
Definitely faster, yeah. So I guess we recap. I guess we want configuration for opt-in. Then depending on that, in the module, you would either start the loop or not start the loop. You would implement a leader election module. That means extra method on the module that checks configuration object and returns true or false. If it wants to run, it returns true. If it doesn't want to run, it returns false. that you can see how this works in the GitOps module. Again, I can share the screen here.
And Vishal's like flying to
Yes.
America right now, so you're like gonna have all this done in the next couple of days, right, Guillermo, on your branch?
I'm gonna have what, sorry?
You're gonna have all this stuff we're talking about done in the next couple of days on your branch, right?
I don't know if done, but at least halfway done. I'll definitely change the loop.
Yeah, Vishal's gonna be like in the South Bay. I'm gonna see him probably, starting on the 22nd or something. We'll meet up at least once, maybe pair together.
Nice.
So I was just saying that this is how you do a leader election here. Check the config if you want this run method to be started, you just return true, and this is documented.
Is runnable configuration.
Well, it's documented here. Like when this is invoked, when this is true, like basically. This run is the same as this run, and this interface embeds this interface, but it just documents how this is different versus this. But basically, you will look at the config. Like this here is if there are manifest projects, then it returns true. So this is executed, and then this looks at the manifest projects and, well, looks at the config basically, and blah, blah, blah. You will be doing something like that.
This is in manifest ops agent module.
Yeah, well, ChartOps does the same thing basically. But
What
it
is
just looks at the
module
charts.
for? That's just the basic plumbing for the module, or like what is supposed to be in module.go? Like what?
Well, you have the factory that creates the module, and the module is the implementation of the module interface.
Okay.
Of the run method, and possibly in our case is runnable configuration, because it needs to have a little like leader election.
And defaulting as well. So 3 things. Run, defaulting, the name of the module, and then you also have the runnable configuration. And there's another one, another module. So these are 2 GitOps modules, and then this is the vulnerability. It always returns true because it always wants to be polling at the server. So agent K always does leader election. This was optional, but then it became like that, hard-coded.
Okay, I don't want to take all of your time. When are you leaving at the end of this week, Mikhail?
Thursday.
Okay.
My first day off, but I'm off for 2 days. On Monday I will be back.
Okay.
I think, unless I have requested more leave, but it will be in a week. So next week I will be working, and then after that there are holidays.
Do you have any more questions, Guillermo?
Not at the moment. There might be when I start trying to write this code, but for now,
we had the video.
I think it's clear. Yeah, that's a good thing. I've
Really
also been writing notes.
Yeah, I really appreciate it, Mikhail.
So I'm thinking of no problem. So I'm thinking of, again, for the future, not right now, like this API to make the request from the agent. I'm thinking of adding a new method there to do what we have discussed, basically, to do the long polling between agent and CAS doing the actual tight polling loop, but also make it so that on the CAS side, this is not a pre-built module like the one that is for the simple request response.
A what module?
A pre-built module, right?
Pre-built, yeah. So when you call the make request from the agent, it actually on the server, it's handled by the GitLab Access.
I don't know where you're saying previewed,
Pre-built, I think.
pre-built. Okay.
Is that a word? I just made it up. I
Yeah.
don't know.
Pre-built. Oh, okay, I got it. It's
Yeah.
not there yet.
Previously built.
Yeah. So this GitLab Access handles the make request that comes from the agent and does the request to Rails. So I'm thinking of building something like this, but not as a pre-built module, so like this GitLab Access, but as a library, so that on CAS side, in your remote dev, you can use this as a building block, but then make it easy to plug in the notification mechanism so that when CAS is poked by Rails and broadcasts a notification, and then potentially another instance of CAS receives that notification, it can poke kind of itself to do the another poll, basically. And because this might be useful for other things, and like for leader election, that's like I built it as a reusable machinery in the agent, and then multiple modules use that. And for this, I think it would be better to also build it as a reusable machinery for future potential reuse. But again, that's for later. I'm just sharing thoughts. And another thought I had is that polling that CAS would be doing, the tight polling loop. We can use e-tags, the HTTP caching mechanism, where the Rails would reply with an e-tag, and then CAS would use that e-tag to make the next call, and then Rails can check if the data it has to reply with matches the e-tag or it doesn't match the e-tag. If it doesn't, it can say no content, 204. And if it, maybe there is a special reply actually. I'm not sure. Probably no content. And then if it does have something to reply with, it would reply and say, here's the new e-tag. And then that generic polling logic in CAS would not need to, it can stay generic, basically. It would not need to understand if it should return or it should not return this particular reply. It would just compare, if it's 204, no content, then doesn't need to reply. And if it's 200, then it just replies to the agent. That's how it can stay generic, plus do caching, plus do notifications, be aware of notifications. I guess what I'm saying is, sorry?
What level would the caching be at? Like what would be cached and where? Do you imagining?
So CAS would be polling at the same intervals, but it would just do HTTP level. It's like state attached to the connection itself, I guess. You can view it like that. And then that e-tag would be returned to agents. It's like for GitOps, CAS returns the commit ID, then agent, when it polls with a outer loop polling, it sends the commit ID, then agent, then CAS polls git.ly with that commit ID. If the commit is the same commit on the branch, CAS doesn't have to return anything. So that would be the same idea with e-tag.
Yeah, if the state is the same, don't.
Yeah, the state is the same,
K.
then we don't exactly. We don't need to generate any reply traffic, basically, if the e-tag is the same. And that can be a generic mechanism that is reusable for other polling modules, not only for remote dev module. So I guess what I'm saying is I will build it for you. So for now, just do the straightforward version.
The simple solution.
So nothing is technically being cached. It's just using the HTTP statuses to save work.
The e-tag header.
It's the HTTP caching part of caching, but nothing is actually cached somewhere.
Right.
Oh, you can actually cache something on the Rails side, but that's that's internal implementation detail, how you would reply with no content or here is content, I mean, the dump version would compute the result, hash it, and that's how you would get the E tag. And that if that matches the E tag that the client sent, that you would just say no reply, no response, 204. But that's still doing work on the server side. Then you can do a bit, I don't know, somehow record in Redis that there were no changes to this agent ID or something like that since this timestamp. And then polling would check Redis and see that there's nothing to do and not even touch the database. But that's all in for the future, of course. I'm just thinking about it.
Yeah, feature optimizations.
Yeah. For now, we don't need to do any of that.
And these are all indexed by the agent ID and the workstation ID. So it'll
by the agent ID, right? Because the workstation ID.
Well, every record in the Postgres table will be like a single workstation. So like that would be basically the
primary index, and then the secondary index would be by the agent ID.
Right, and that will together those will be the cache key. You know, if we ended up storing this in Redis.
Something like that.
Okay, I think it's good. Thank you so much.
Thanks.
We keep iterating on the architecture. We're getting closer every time.
Yeah.
All right. Bye.
Bye.
You're gonna share this in the remote dev channel?
Yeah, I will upload it and share. Yeah.
Okay. Thanks. Bye.